Hello everyone, welcome to IIT and GATE classes. This is lecture 15 on operating system. As you all have requested that the previous lecture which I have made has no voice, I forgot to unmute. So I am taking this same lecture again. Okay. So in this lecture we are going to start segmentation. Okay. So first of all we should know why we need this segmentation technique when already we have paging. We have already studied paging technique. Then why we are going to study this segmentation? Answer is very simple. See this. In paging technique, what we are doing is process is divided into fixed and equal size parts called pages. Now since we have taken fixed and equal size parts, so chances are there that the for loop body, or you can say for loop statement, is here. Okay, and its body goes here. Are you getting it? So for example, I have written a loop for I is equal to 1, I less than equal to 1000 and I plus plus. And here is the body of the loop. So now chances are there that this, because we are doing fixed and equal size parts in paging, fixed and equal size parts called pages, processes divided into fixed and equal size parts. Since parts are of equal sizes, so chances might be there that this is some code here, and till this point page is over. Okay, one page. Now another page will start from this. So imagine that this is your page number 1 and this is the page number 2, of the process. So obviously part of the loop statement of the loop is in page 1 and the body of the loop is in page 2. So now obviously this page 1 will be stored in any frame of the main memory for example, here it is stored. Okay, so here we have stored page number 1 of the process, and this page number 2 is, let us suppose, stored here, page 2 here. So now when you start execution of the loop, then from page 1 to page 2, that means from this location of the main memory to this location we will go, and then again we will come back. So we will keep on toggling. Okay, so from this to this, from this to this, and so on. That means it will simply waste our time. Okay, so the process execution will be very slow. Process execution will be slow. Okay, so that was the biggest disadvantage of paging. That's why segmentation was, you can say, developed. So biggest disadvantage of paging is because we are dividing process into fixed and equal size parts called pages. So chances are there that the loop statement goes to one page but its body goes to another page. So we keep on toggling between multiple pages. Okay, and that will create very big problem for us. That means process execution will be very slow. So we want to avoid this scenario. So for that, segmentation technique was developed. Okay, so how we will you can say develop this. So let me give you some idea. Let me jump to the next slide. Take the snapshot. Yeah. So now, for example, what segmentation is saying, I will tell you this now. What segmentation is saying. Okay, so segmentation is saying that you should not divide process into fixed and equal size parts. Of course, that paging was saying. Segmentation is not saying like that. You should not divide process into fixed and equal size parts. Rather, you should divide the process according to your functions. According to functions, you can divide. For example, process is having, or you can say you have written a program. Program is having main function. Okay, and then you have, say, sqrt function to find the square root. Okay, and then you have add function in the program. Okay, and let us suppose we have another function like say subtraction, sub. Okay, so this is the program which we are having. Okay, yes. So so what we will do, so this will become our first segment. This will be your first segment, this will be your second segment, this is the third segment, and this is the fourth segment. Okay, and in main memory, wherever we have place, we will try to put them. So for example, main is stored here. Okay, here main is stored, sqrt is stored here. Okay, and so on. I think you have got it. And obviously for main we need contiguous memory allocation. Okay, so entire main will be stored in contiguous location in the main memory. Okay, so for example, main is of say 1000 byte. Well, I'm just giving you an idea. So 1000 contiguous bytes you need in main memory to store main. Then sqrt say suppose 500 bytes. Then obviously for this we need 500 byte contiguous space in main memory, and so on. So obviously now you have got it that segments may be of different sizes. Let me write it so that you get more clarity. Segments of the process or program. Segments may be of different sizes. Okay, segments may be of different sizes. Now since segments may be of different sizes, so obviously main memory we cannot divide it into fixed and equal size parts called frames. As we have studied in paging, main memory was divided into, say this, main memory was divided into fixed and equal size parts called frames. But here we cannot do it. Okay, so directly in paging what we were using, mft we were using, but here we are using mvt, multi-programming with variable number of tasks. If you do not know all these things, watch my previous lectures. What is mft, what is mvt, and so on, I have explained clearly in the previous lectures itself. Okay, so mft was used in paging, but mvt is used in segmentation. Okay, now you already know mvt was difficult to implement, mft was very easy to implement, so obviously segmentation is difficult to implement. Segmentation is difficult to implement. Why it is difficult? Because in order to give contiguous space to the process, we have to keep record of all the, you can say, holes in the main memory and so on. I have told you many times in the previous lectures also, mvt is difficult to implement. So obviously segmentation will be difficult to implement. It is not that easy like your paging. Okay, don't worry, I will give you idea that how we are implementing it, then you will get more clarity. Okay, and the second basic difference is MBT is used in segmentation, but MFT is used in paging. I have already told you many times. Okay, so take the snapshot of this, then I will jump to the next slide. Hmm. So this is the basic idea of segmentation. That means we will divide the process according to functions. So depending upon the space available in main memory, we will store the process functions continuously. So obviously when we are storing continuously, so we cannot imagine that body of the loop goes to one at some place and loop statement is at some other place. We cannot imagine like that because we have contiguous memory. Okay, yeah, so I hope you have got it. So now let me give you a small idea that how we are going to implement it. Let me jump to the next slide. So assume process is having say four functions: main, sqrt, whatever we have written, a main, sqrt, add, and sub. Okay, so what we will say, see, the cpu generated address, that is logical address, earlier it was divided into p and d, page number and offset within page. So now we will be having s and d, segment number and offset within the segment. Okay, this is the segment number and this is the offset within segment. Now for example, we have four you can say functions. So just like your paging, we have the same logical address divided into two parts, and just like paging we have page map table, so here we will have segment table. So simple. So let us suppose this is our segment table. Okay, now segment table will have two entries, limit and base. Okay, so how many entries will be there? Four entries will be there. Okay, so each entry has two parts, limit and base. Each entry has two parts, limit and base. Why four entries? Because four functions were there. Okay, that is very obvious. Okay, so now let us suppose this is our main memory. So in this main memory, first of all we have stored main function. Okay, we have stored, let us suppose, main function, and starting from say location 1000 to 1999, that is our main. Now assume that till 2500 location some other process segments are stored, and at 2500 we are going to start subtraction sub, so 2499 we will take till 2499, some other process was there. Okay, and now from 2500 we are going to start our subtraction function sub, and it is going till 3499. Now from 4000 location, okay, till 4499 we have sqrt function, and then from 5000, let us suppose from 5000 location, from 5249, we are going to store add function. So directly indirectly we can calculate the size also. Okay, so main is of say 1000 bytes. That's why we are taken from 1000 to 1999, 2500 to 3499, again 1000 bytes, then 4000 to this is 500, and this is 250. So main is of 1000, subtraction is of 1000, square root is of 500, and add is of 250. I'm just assuming. Okay, do not say sir square root function should be bigger than subtraction function and so on. I'm just assuming the things. Okay, yes. So what we are going to store is, so the sizes will be stored here in the limit field. So main function size is 1000, then subtraction function size is 1000, square root function is 500, and add function is 250. We will store it. Base means starting location, from where it is has started. So 1000 location main is started, 2500 subtraction is started, and then 4000 sqrt started, and then add is started from 5000. I hope everybody have got this point. Now what we are going to do is, so whatever segment, see this in paging also, what we do, if this was the page number, then we will skip those many entries. The next entry will be ours entry. I think you already know p and d na. So p, we will skip p entries, next entry will be ours. So same is the scenario here. S, so we will, so s is suppose 2, s is 2. 2 means what? You will skip first two entries, next entry will be yours, because entry start from 0, 0, 1 and 2. I hope you have got it. Yes. So now what we are going to do is, first of all, we are going to match. Okay, step number 1 I should write. Let me use another color. Step number 1. See, CPU generated address, that is divided into two parts, S and D. Unlike paging, CPU was having no knowledge about paging, because that was our internal adjustment. But for segmentation, CPU must have knowledge. Why? Because the crucial thing is segment number. So there are multiple ways to assign segment number. One way is the way in which we have stored these segments in main memory. Second is the way it has been written in the program. So for example, in the program, you have written first, let me see the previous one, main sqrt add sub. So see this, you have in the program itself, you have written main sqrt add sub. So you can give main as 00 segment number, then 01, then 10, and then 11. I hope you have got it. 0001 10 11, like this. You can number them according to the program. But so another way is according to the locations where these are stored in the main memory. So main will be given 00, then 01, then 10, then 11. So we can label any ways. So there are multiple ways. So CPU has to generate segment number very carefully. So directly and indirectly it means that CPU should have knowledge, or rather we should say CPU must have knowledge about segmentation has been done. Okay, yeah. So CPU saying segment 2, and offset means where you want to go in the segment. So for example, a CPU wants to access a 500 location. Okay, so segment to 500, this is our logical address. So now this 500, first of all you have to match with the limit value. Okay, so if limit value is say for example more, okay, let me give you some idea so that you get more clarity. From 4000 location, you are starting this segment number 2. You can check it out. From 4000 location you are starting segment number 2, and you want to access 500 byte. So 500 byte you want to access means what? 4000 will be added with 500 na? Then you will get 4500, but 4500 is outside, so you cannot access it. Okay, so if you are having confusion, since it is a boundary condition, so I can take some other value. For example, I take say 700. So now directly indirectly it means you want to access 700 byte, but actually its size is only 500. So how you can access 700? That is not allowed. So we will generate trap in this case. So what we will say, D, and we are going to match it with your limit value. Okay. So D and this limit is matched. If limit is more, strictly more, then it's okay. If it is answer is no, then we will generate a trap. I hope you have got it. So what we are doing is offset of the segment and the limit value are compared. If limit value is strictly greater, then it's okay. Otherwise, we will generate a trap. Why we are generating trap? I think you have got it. Base address is 4000. So from 4000 location in the main memory, we are starting this SQRT segment. Okay, from 4000 location we are starting it. Now if you say 700, that means 4000 plus 700, 4700 location. How you will access 4700 location? That is not in the SQRT function. So I hope you have got the point. So directly it means we are going to generate a trap here. Okay, yeah, but if it satisfies, then what we are going to do is, if it is yes, then we will take we will take the base address, and we are going to add this offset value. We will go to the main memory location and access the data. So I hope you have got it. So what we are doing is, if it is yes, then 4000, then plus this, and then we will go to main memory and access the data. But since it is no, so we have generated a trap. Now for example, CPU wants to access say 250. Okay, let me use another color. So CPU wants to access say 250. So what you are going to do is 250. First of all, you will match with the limit value. Yes, 250 is less than 500. So obviously we can access the data. Then we will add this 250 with the base value, that is 4000. So finally you will go to 4250 location and access the data, and it will be in SQRT function itself. So I hope you all have got the point what I want to say here. Okay. So in case of no, we are going to generate a trap, but in case of yes, in case of no, we are generating a trap, but in case of yes, what we are doing is we are adding the base value and the offset, and then we will go to the main memory and access the data. Okay. So I hope everybody have got it. So this is all about segmentation. Okay, and numerical questions chances are very less from this topic. Okay, so at most what they can ask, process is having say 4 functions, how many entries will be there in segment table, we can easily guess it out. Okay, and sometimes they might say CPU generated address is 2 and 700, so what location we will get the data. So you will say trap will be generated, and they will say segment 2 and location 250. So what is the physical address? What is the physical address? What you are going to say? See, this is the logical, and what we are getting now is physical. That means 4250. This is the physical address. Of course, I am doing everything in decimal so that we should not waste unnecessary time here. Okay, so we are doing it in decimal. And by the way, numericals have not been asked. Otherwise, we have to change it in binary. 4250. It will take a lot of time to convert it into binary and so on. I'm telling you all this because I think you already know computer can understand only binary. It cannot understand decimal. And obviously this address will be binary only. Just for the sake of simplicity, I have said segment to 700. So it will be binary. Okay, so I hope you have got it. So 250 plus 4000, that is 4250, that will be the physical address. So logical address is 250. Logical address is 250, like this. Two parts. Logical address is having two parts, 2 and 250. And what is the physical address? What we are getting? 4250 is the physical address, whatever we are getting. So I hope you have got this point. Yes. So let me jump to the next slide. You can take snapshot of this. Okay. So I hope you have got it that chances of getting numerical from this topic is almost negligible. Okay, so how they will make the numerical? Okay, so like in paging we have entry size, okay, and the number of entries. Number of entries is okay. Entry size, that will be variable, na. Limit value size is 1000, base is also 1000. Okay, so 1000 will be stored in 10 by 10 bits, and this 1000 is 10 bits, 10 plus 10, 20. So 20 bits are needed for one entry. Similarly here some other values are there, so obviously that will create a lot of problem. Each entry size may be of variable sizes. Okay, so of course that is bit difficult kind of things and all, so that's why I'm not jumping into unnecessary details, because it has not been asked in gate. Okay, so if the questions have not been asked, then why we should waste time here on doing these extra things. So I hope you have got the point. So you can take the snapshot. I will jump to the next slide now. Okay, so I hope everybody have taken it. Hmm. So you should have just a basic idea of what exactly segmentation is doing and all. Okay, yes, so now we are going to start our demand paging, another topic, demand paging. Okay, so I will say the biggest, you can say, disadvantage, biggest disadvantage of paging and segmentation. P&S means paging and segmentation, is that your all the pages or segments, all pages or segments must be in main memory to start execution. So if you want to start execution of a process, then you have to load all the pages or all the segments in the main memory itself. But if we see carefully, CPU generated address, that is logical address, it might be POD or it might be SOD, whatever may be the situation. This is situation in paging and this is in segmentation. So CPU want just one byte of, you can say CPU want to access just one byte. Okay, or you can say one word also, but that is architecture term. I think you already know what is byte and word and so on. So CPU want this only. Okay, and you have stored entire process in main memory. So just like that, I will give you a small example. You go to some marriage, okay, and you pick up the plate. You are very hungry, so you will put all everything in your plate. So your plate will be like this, very huge. So everybody will say, see how he is eating and all. That will create a big mess in your mind. So what is the better idea? You take a plate, you put small amount of things, you just eat it. Then again you put small other small kind of things, or small, you can say let us suppose two chapatis and one sabji and one roti and so on, whatever way you want, you can say that. So small things you keep and then you eat, then again you keep and then you eat and so on. That is the best way. So same is the scenario here. CPU just want one byte or one word. So why you are keeping all the pages and all the segments in main memory when CPU does not need them at a time? At a time I'm using the word. Obviously CPU needs them, but at presently or at a given time, it does not want multiple pages or segments. Okay, so forget about pages or segment. CPU just want one byte. Okay, yes. So this is not good idea that you keep all the pages or all the segments in main memory. Rather, the page or the segment which you want, that should be, you can say, that should be in main memory. Okay, and by the way, topic name is demand paging, so we will consider on paging only. We will not consider on segmentation. Demand segmentation also is there, but that is not required for gate. That is just wastage of time, so I'm not jumping into that. So we will use the word pages only, pages and frames, because it is demand paging. Okay, so I was just telling you the disadvantage. That's why I have used the word paging and pages and segments, you can say, interchangeably. But I was just discussing the disadvantage. That's why. Okay, but we are studying the topic demand paging, so we should say pages or frames. Yes. So CPU generated address, that is divided into two parts, P and D. So CPU just want to access one page at a time. Okay. Rather more precisely, it just want one byte or word. So why you are keeping all the things or all the pages in main memory? that is not good. So that's why demand paging technique was developed. Demand paging means on demand basis it will run. So when CPU generated address is PND and this page number is not in main memory, then what we will say, if this page is not in main memory, then we will swap in that page. Okay, so on demand basis, everything will be on demand basis. That is known as demand paging. Okay, so I hope you have got the point what exactly is demand paging. So we will swap in page on demand basis. Okay, so here we will use, take the snapshot. I hope you have taken it. So here we are going to use lazy swapper. Lazy swapper. So lazy swapper, as the name suggests, it is very lazy. That means it will swap in page only on demand basis. If there is no demand from CPU, that will be kept in hard disk only. So swap in page purely on demand basis. Purely on demand basis. Okay, that is the basic meaning of lazy swapper. So lazy swapper will swap in page purely on demand basis. Whenever CPU will create a demand, or like CPU generated address P and D, so this P is not in main memory. Okay, so okay, and one more thing, how you will come to know that this page is not in main memory? So for that, let me give you some idea. See, earlier page map table was having frame number entries, na? Try to imagine the you can say paging technique. So this is a frame 1, frame 2, whatever maybe the frames, frame numbers, whatever you are keeping. So with each and every entry in page map table, we will have an extra bit called valid invalid bit. I means invalid, V means valid. So you can consider I means 0, valid means 1. So 0 or 1. So with each entry of PMT, let me write it. It is very important point. Each entry of PMT, each entry of PMT will have, what I'm using the word, please concentrate, each entry, each and every entry, okay, of PMT will have one extra bit called valid invalid bit. Valid invalid bit. Okay, each entry of PMT will have one extra bit called valid invalid bit. Okay, so it's your wish, whatever way you want you can keep. I means 0, V means 1, or I means 1, V means 0, whatever way you want. Are you getting it? I means 0 or 1, whatever way you want you can take. V means 0 or 1, whatever way you want you can take. Okay, of course, if I is 0, V should be 1. If I is 1, V should be 0. Okay, so two values, na, you have just two values. Bit can have only two values, 0 or 1. So it's your wish. For 0 you are taking invalid, or for 0 you are taking valid. It's your wish. For 1 you are taking invalid, or for 1 you are taking valid. It's your wish. So I hope you have got it. So each entry of PMT will have one extra bit called valid invalid bit. Okay, yeah. So if this entry is invalid, that means what? Whatever CPU is demanding the page, that page is not in main memory. So now we will say page fault has occurred. We will use the word page fault. Page fault has occurred. So I hope you are getting it. So whenever CPU generated address that is divided into two parts, P and D, this P means what? You will skip the P entries. Next entry will be yours. Now in this entry, if we have I set, if we have I, that means this entry is invalid. This entry invalid means the corresponding page is not in main memory, it is in hard disk. So we have to swap in that page. So in that scenario, we will say that page fault has occurred. So whenever CPU generated address P, you will skip P entry, next entry will be yours. If this entry is I, that means page fault has occurred. If this entry is V, that means no page fault, it is in main memory only. Okay, if this entry is V, means page in main memory. Okay, I means page not in main memory. Page not in main memory. If I we will say page is not in main memory, and we will say page fault has occurred. Okay, and page in main memory means V. Valid means it is in main memory. So I hope you have got the point. Okay. Yes. So this is how we you can say we will come to know that page is in main memory or it is not in main memory. So we will have an entry valid or invalid. Okay. So that's it. So this is all about your you can say demand paging basic introduction. Okay, so the basic idea of demand paging is that we will swap in page purely on demand basis. So whenever CPU generated address, the page number we have, we will check the page number entry in the you can say in page map table. So we will skip first P entry, next entry will be your in page map table. If I is present, then we will say page is not in main memory and page fault has occurred. If V is present, then we will say page in main memory. So just go to main memory and get the data. So you will replace this P by F and D, and you will go to main memory and access the data. I think I have told you all these things many times in paging itself. So I hope you all have got the point. Okay. So this is all about the basic introduction to demand paging. Okay. Hmm. So that's all for today. In the next class, we will make a very beautiful, you can say, diagram. Okay, that diagram will give you more clarity about how demand paging is, you can say, implemented and all. Okay, so next will be flow chart of demand paging. In the next lecture, we are going to start flow chart of demand paging. After flowchart is over, we will solve one or two numericals of demand paging, and then we will shift to very important topic, that is the page replacement policies. How pages will be replaced. Okay, so for that we have FIFO, optimal, LRU. These three are mostly used, and many times question have been asked in GATE from this topic also. So we will study these three page replacement algorithms, and after studying page replacement algorithms, we will simply give you small idea of you can say hard disk. Okay, so seek time, latency time, I think you have studied that in your computer architecture itself. So I will give you small idea about disk scheduling algorithms, FIFO, shortest seek time first. Okay, look see scan and so on, we will study these. Okay. Yes, so I hope everything is fit and fine. So we will wind up the class here itself. In the next lecture, we will resume this. Most probably today or tomorrow, I will make that lecture also. So don't worry about it. Okay then. Thank you so much. Bye bye.